Okay, so without further ado, DURI in the real world, challenges and benefits. My name is Jamie Guidriaville, and I'm one of the co-leads of the Data Use and Researchers Identities workstream, along with my esteemed colleague, Dr. Tommy Naronin. And today you will hear some examples of our standards that are being used by driver projects and collaborators worldwide. And I just wanted to provide a very brief introduction to DURI for those who may be new to GA4GH or our particular workstream. The DURI activities are applicable to many genomics and health data sharing use cases, and we do expect to continually expand on the future roadmap based on an increasing level of interest in facilitating data access. Okay, hopefully the slide changed. I can't tell so much from my end, but the data use portion of DURI focuses on secondary data use of human research data, particularly those that may be sensitive data. Our DUO, or Data Use Ontology, technical focus to facilitate data access, which is led by Melanie Courteau and Jonathan Lawson, enables unambiguous coding of allowable data uses that are interoperable with legal or regulatory, operational, and semantics frameworks. This workstream is currently working on improving existing DUO code definitions of allowable data use or restricted data use to make them easier to understand and implement by a variety of stakeholders in both research and the clinical or healthcare settings. The DURI leads and team members further collaborate with other workstreams that you may be joining throughout these sessions, including the regulatory and ethics workstream, cloud, discovery, and authentication and authorization implementation, so that standards can be applied to as many driver projects across GA4GH as is possible. One key example for the data use team includes ongoing collaborations with the regulatory and ethics workstream on the new machine readable consent standard that you may be hearing about, where DUO codes for allowable data use can be added into consents as clauses which can be consistently understood across multiple environments. The DURI workstream teams are also looking to enhance current documentation for the DUO coding, as well as respective interpretations and some translation of those. In addition, the recent gap analysis had identified a potential need for inclusion of clinically relevant DUO codes, and DURI is excited to explore possible use cases for that type of request. And as you can see, we work with a number of driver projects on this effort. So the establishing researcher identities portion comprises the remaining DURI workstream focus, and it really hones in on specifying the researchers who will gain access to sensitive human data and the credentials that confirm their approved roles. The researcher identity focus of DURI is encompassed in the Passports technical access that is led by our technical leads, Sarian Bowers and Craig Voisin, and it enables coding of researchers' permissions to access various data and services. The Passports workstream is consulting with various data access committees, or DACs, to learn their processes and work to offer solutions. One recent example of collaborative implementation of the Passport standard was through the newly established and published NIH RAS visa, which required some customization and a bit of discussion between stakeholders to resolve. And we use this as an example because there is a desire to improve solutions for groups that are using GA4GH standards, and to the degree possible to be able to implement within their current systems. And we want to have an ultimate goal of taking those customization instances and moving those forward towards something that's more globally consistent in upgrades in the future. Our Passport workstream members are also working across GA4GH workstreams collaboratively. And importantly, the gap analysis had identified opportunities and recommendations for Passports to interoperate with both the discovery and cloud workstream standards, including the FASP efforts that have been highlighted here during this plenary. And I would encourage everyone to also, as you can, look into those efforts. Last but not least, the DURI has been supporting COVID-19 research through technical standardization of data sharing in existing platforms, for example, COVID-19 Europe. The technology stack for sharing the sensitive data that's landing on the European data portal leverages GA4GH driver projects, EGA specifically, and many of the active partners are affiliated with GA4GH in that effort, including my DURI co-lead, Dr. Tommy Noronen. Data controlled technology standards like GA4GH Passport will be necessary to establish trust on an appropriate data sharing throughout critical areas of public health, like COVID-19. This is just a schematic to show a bit about how both standards work together. I'm not going to get into it, but I just wanted to use it as a jumping off platform to reach out and say that Tommy and I want to take a moment to very quickly acknowledge and thank our DURI leads and workstream members for their hard work and dedication to all of these efforts that I briefly introduced, that you will hear about today, and what goes on behind the scenes, particularly throughout this COVID-19 time globally. And we certainly understand that much of this work is being done with limited time and resources and on a voluntary basis, and we very much appreciate everyone trying to push through and find a balance to make it work. For purposes here today in the presentations, we certainly encourage everyone to reach out and look at the GA4GH website or contact any of us on the DURI leadership team for more information on what we do and how to become involved. And again, thank you for joining us today, and I hope that you will enjoy today's presentations.
Hi, I'm Rebecca Rosen. I'm the product owner for the NIH Researcher Auth Service. It's an initiative funded by the NIH Office of Data Science Strategy. It's Susan Gregorick, and it's in line with the NIH Data Science, the Strategic Plan for Data Science. The service is hosted by the Center for Information Technology and the Identity, Credential, and Access Management Service by Jeffrey Erickson. The vision for the Researcher Auth service is to provide to researchers both inside and outside NIH a secure, efficient, and unified auth service whereby they can log in to data repositories within the NIH data ecosystem and access both data and services to which they are authorized. And it also provides methods of logging and auditing such events. The idea is that you can log in with various credentials, be they NIH credentials or various preferred credentials, some of which are shown on this slide. The Researcher Auth service is being developed to adhere to various standards and guidelines, including GA4GH. We have OAuth OIDC as our B2C and B2B use case requirements. We are also a FISMA high system, and so we have various NIST controls that we must implement. We are adherent to the GA4GH Authentication and Authorization Infrastructure Standard, and we are also adhering to the GA4GH DURI Passport and Visa standards. We've already contributed a custom visa to this protocol. We're also going to be adherent to GDPR requirements, as there will be appropriate data sets within the NIH data ecosystem that require this compliance. The Researcher Auth service is being developed using Agile project management methodology, and this means we're developing it in phases. And we're working directly with partner systems who will be consuming the services from RAS, and this allows us to design it with their use cases in mind. The first release, the V1 that I'll describe in a minute, was defined precisely for these 4 data platforms. These are our phase 1 partner systems: the Office of the Directors, Kids First Data Resource Center, NHLBI's Biodata Catalyst, NCI's Cancer Research Data Commons, and NHGRI's Anvil. We are now working with the phase 2 partner systems to define the requirements for the next deploy of the RAS service, and that is in collaboration with NCBI's dbGaP, Common Fund Data Ecosystem, Office of the Directors All of Us program, and NIMH's Data Archive. And this is what the RAS V1 service looks like. This is a set of services that were recently deployed into production. Users can log into any one of those 4 partner systems using NIH or ERA Commons credentials. They'll receive back an ID and an access token, and the client can then call back the RAS user info service to receive GA4GH compliant passports and visas. And on the right, you'll see an example of what that passport and visa looks like. At the top is just the basic information that is compliant with the current passport standard. And then you'll see what the dbGaP RAS custom visa looks like. And each of these blocks is a permission block that describes a data set. This is a PHS ID, it's the name of the data set. That this user is authorized to access, as well as the consent group, the version, and the participant set within the data set that the user is authorized to access, the role of that researcher, in this case it's a PI, and the expiration date of those permissions. And as I mentioned, this visa is registered with the new custom visa registry within GA4GH's standards. We did find that there was some room for interpretation within the AAI framework for using the visas and passport tokens generated by a passport broker like RAS. And so we created additional guidance for the partner systems within the NIH data ecosystem, and we're making those available on our service offerings website, which is a public resource, and the link is below. Specifically, we provided guidance about how the root access token can and cannot be used by the partner clients. The root access token must not be passed by the client to downstream applications. Rather, we require that the visas can be used to provide user entitlements to downstream applications. And this means that the root access token shouldn't be used to feed workflows, DRS servers, or clearinghouses. Rather, the clients can generate their own tokens, or they can use the visa to communicate with those downstream applications. And again, all of this information about what RASB1 looks like is available for public access on our website. And thank you for having me. Any questions should be directed to our team or to me, and here's some links for additional information on the Researcher Auth service.
Good day, everyone. My name is Michele Mattioni, and today I will present to you how the different 7 Bridges programs are supporting the development of the GA4GH standards, and I will focus on our work done in integrating with the research of service via the GA4GH Passport. We have currently 3 programs in 7 Bridges, which are Biodata Catalyst, done in collaboration with the NHLBI, the Cancer Genomics Cloud, which is our oldest program working together with the NCI, and Cavatica, which is part of the Kids First Gabriella Miller. With these 3 different programs, we are working on several work streams within the GA4GH. As I said, in the DURI work stream, we are working on the GA4GH Passport, and we are actively integrating that with RAS. We are working also on the cloud work stream, where we are actively supporting DURS and WES, and we have presented last year 2 their servers, running one on Cavatica and one on CGC, which are both up in production, and they are able to serve, control, and open data. We are also working towards FHIR as one possible way to support interoperability for clinical and phenotypical data, and we are participating in reviews for the data license initiative. So I wanted to give a shout out to the team that is mostly closely involved in the RAS integration, and whom they have worked with all the other stakeholders to move the project forward, which are like Manisha, Jaco, Stefan, and Mia. So when we started this project, 3 different milestones were identified. The first one, which is what we are presenting today, was to use RAS as the authentication system, and then use FANS for the authorization, which was using dbGaP telemetry file to provide that. So these other 2 milestones were identified at that time. This is an ongoing process, and things can change. This work is done together with all the other stacks in the CRDCs, and so I'm going to present milestone 1, where we are today. So you can see on the left the 7 Bridges stack, and on the right there is a FANS with RAS. So the authentication is managed by the account service on 7 Bridges, which logs with RAS and sends over the consent to both RAS and FANS. This then provides the GA4GH to the ODC service, which then is able to talk back to fence, which which then talks to RAS and then can confirm the user and can then give the authorization to the data. When the data are authorized, those can then be put into the platform and they can be used in the workflows or in the interactive analysis. So I want to also take a minute to what we think like is could be the path forward. So GA4GH standards have been extremely useful to democratize the access to data and resource with a safe and secure approach. So that's why we are supporting this in our platforms, and we are building supports for new standards that are coming out. At the same level, we think it's extremely important that those standards are really widespread across actors, institutions, also at international level, which then provides the possibility to significantly accelerate the ability to create a strong ecosystem for researchers and scientists, and with having basically a global outreach to go after the research in all the needs that needs to be done. So I wanted to thank you for the time that you're giving to me and for having me at the plenary. If you have any questions, given the time was short, feel free to send me an email. And if you want, you can try the platform. I left here the links that will guide you to the login page, and then you can basically check them out. So thank you very much, and goodbye for now.
Hello, everyone. Thanks for having me here today to talk about how the National Human Genome Research Institute, NHGRI, is piloting an innovative application of the GA4GH Data Use Ontology standard. My name is Elena. I am a policy analyst at NHGRI, one of the 27 institutes and centers at the National Institutes of Health. In 2018, our institute began funding a cloud commons for genomics called Anvil to make it easier for researchers to work with large-scale genomics data. However, it is not enough to scale up computing and storage. We also need to change the way that access to data is governed, which is currently through manual review by data access committees at NIH. We believe that with the ever-increasing number of researchers interested in using a burgeoning amount of genomics data, there will be a scaling issues for data access committees to keep up with the requests. To address this scaling issue, Anvil is piloting the Data Use Oversight System, DUOS, a platform developed by the Broad Institute to make the data access request process more efficient for both researchers and data access committees. DUOS can be thought of as both a researcher portal for applying for data access and a decision support tool for data access committees, and helps bring these two groups together. NHGRI is guiding the development of this tool's interfaces and workflows, as well as testing the use of DUOS's matching algorithm, which connects the researcher's requests with the data access committee through semantic technologies such as ontologies. So far, we've tested approximately 100 prior researcher requests to NHGRI datasets through DUOS, overly selecting for more challenging use cases. Results have been promising, with good concordance between the algorithm's recommendations and the data access committee's ultimate decision. Additional questions were added to the data access request form to get at aspects of the decision that were not originally being captured and that caused misalignment between the algorithm and the decision of the data access committee. With further refinements, we hope to get to a point where the algorithm is increasingly useful in supporting the data access committee's decisions. We plan to test DUOS with real-time researcher requests in the coming months. If proven successful, we believe that DUOS and its implementation of the Data Use Ontology standard will help to further standardize and streamline the data access request process. As the number of requests for data increase in magnitude over the years, DUOS could help to ensure data access committee members' time is reserved for more fine-grained judgment of requests. We hope that by pursuing the use of this GA4GH international standard, we will support interoperable, ethical, and accelerated genomics research.
In this session, we will see Data Use Ontology and GA4GH Passports at EGA. Data Use Ontology allows EGA to semantically tag datasets with restrictions about their usage. Now, we will see how DUO codes are implemented at EGA. Users are asked to identify DUO codes as part of the submission process. This is done via our SOP for data deposition. Further information on the GA4GH Data Use Ontology can be found at the ebi-spot/duo GitHub page. Now, how the duo codes helps. Suppose we have a research paper of interest. We see that the sequence file have been deposited at the EGA in the provided accession codes. Now we will be able to explore the data use condition tagged to our dataset of interest. Further description for each duo code can be obtained by simply clicking on the respective code links. Duo codes thus allows requester to identify how the data may be used and if they would likely get access. The duo code also helps to mitigate unnecessary application to the data access committees. To illustrate this, suppose a researcher wants to perform general data analysis in bioinformatics. The researcher identifies the dataset of interest at EGA. The researcher sees the duo code 7 and identifies that the use is allowed provided it is related to the specific disease. The disease can be identified through the Monto identifier. Scientists can search on the duo codes, aiding data discoverability. As you can see, there are 38 datasets with the duo code 18 tagged. Scientists. Here are some user feedbacks on the duo usage at EGA. The submitters are happy to know that duo codes can be added at any point of time, even after the data release is done. We have had submitters instructing the EGA helpdesk to use the duo codes as per their previous submissions. The submitters are also content with the flexibility provided to modify duo codes anytime. We also had a user inquiry if duo codes can be added to the dataset XML or to the submitter portal interface. Currently, this is in our future roadmap. And appropriate Monto ontology is also helping the end users to make the data access request better. We also had a submitter wanting not to limit to health, medical, biomedical research, but basic research. Coming to some stats, as of September 2020, we have 625 EGA datasets in distribution with duo codes attached to them. Thank you.
These are use cases and requirements for GA4GH AI integration. This is an Elixir GA4GH eco service. As you can see, there are no records for control access grants and link identities because I haven't linked EGID with Elixir ID. I will now show you how to link EGID with Elixir ID. Linking EGA and Elixir identities allows users to use their Elixir identity to access EGA data and other Elixir resources. These are my EGA credentials. I have selected the organization. My EBI credentials. IDs are getting linked. As you can see, the message request has been processed successfully. It indicates IDs have been linked. Let's check. The Elixir GA4GH eco service. I have selected the organization. I have entered my EBI credentials. Yes, continue. Now you can see, after linking EGA identity with Elixir identity, both control access grant and link identities records can be seen. Thank you.
Hi, I'm Hayley Clissold and I handle our data sharing work at the Wellcome Sanger Institute in the UK, and I'm also the Sanger DAC. It's great to be given the opportunity to talk to you about how we have implemented some of the Global Alliance DURI standards at Sanger. I'm going to talk specifically about how we have applied Data Use Ontologies, or DUO, to the majority of our data sets that we archive in the EGA. I'm going to start with a bit of background on data sharing at Sanger. So we have just short of 1,000 data sets in the EGA, and these can be shared with other researchers according to a data access agreement. We have 9 different types of data access agreement, and most of these are specific agreements for dataset cohorts, such as the DDD study and the HIPSCI initiative. But we also have a standard agreement which covers around half of all of our datasets. Typically, all datasets within a cohort have the same terms of use and usage restrictions, which means that applying DUO is a bit easier because we can apply the same DUO terms to all datasets within that cohort. So an example of one of the first cohorts that we tackled was our Cancer Genome Project cohort, or CGP. And working with cohorts is quite simple because all the datasets were shared under the same type of agreement and they all had the same usage restrictions. So for the large CGP cohort, this meant that we could quickly and easily apply blanket DUO terms to all 325 datasets in the cohort. And you can see here on the slide an example of a cancer dataset with those DUO terms on the EGA website. The trickier part came when we began to apply DUO to 430 datasets that we share according to our standard data access agreement. And these ones are more tricky because although the datasets will share the same terms of use, each dataset can have additional and different usage restrictions, and these obviously must be taken into account when we apply DUO. So currently, any usage restrictions are entered into the system by our research administrators, and they are based within the research teams at Sanger. And they use our data sharing platform, which is called EDAM, to input the usage restrictions manually as free text, as you can see here in this screenshot. Once they have set up the dataset record in EDAM, it opens up the dataset for access by other researchers, and this means that researchers can apply to access that dataset. Now, in the ideal world, this setup would happen as soon as the datasets are made available in the EGA, but quite commonly it usually happens once we get that first person showing an interest in the dataset. Unfortunately, this meant that because there are some datasets that haven't yet been set up in our system, we couldn't apply DURI to them just yet because any additional usage restrictions have not yet been entered into the system. But this is something that we're trying to work on now. So for those datasets that have been set up, we decided to filter out the datasets which had no additional usage restrictions, and these could all be given the blanket DURI terms which satisfy our general terms of use. So there were around 50 datasets that did have additional usage restrictions, and so we went through these one by one to make sure they were tagged with the most appropriate DURI terms to cover their reuse. Once we had added these DURI terms, it meant that we have now applied DURI to 664 Sanger datasets, which is around 70% of all of them. So looking forwards to the future, we're looking at ways to better adapt EDAM to support the implementation of DURI, and particularly to make it more sustainable. So as I've already mentioned, we've applied DURI to the majority of our datasets, but we want to make sure that we have a way of applying DURI to newly generated datasets as and when they become available on the EGA. And hopefully this would ultimately make the datasets more easily found when researchers search the EGA for a specific type of dataset to use in their research. But as well as this, we're also looking at how we can replace that free text box that is used to describe usage restrictions and turning that into applying DURI terms directly. So I've been asked to talk about the benefits and challenges of implementing DURI, and I'll start off with the challenges, but some of these are probably going to be quite Sanger specific. So for us, there were challenges with several datasets that hadn't had their usage restrictions entered into the system, and this meant that we haven't yet been able to apply DURI to them. Another challenge was the time taken to apply DURI to those datasets, which needed to be looked at individually. It really helped being able to filter the datasets and being able to apply a blanket set of DURI terms to most of them, but extra time was needed for a certain subset of the others. But obviously this is just a one-off piece of work which won't need to be done again, and we're planning on implementing a more sustainable way forward for applying DURI to newly generated datasets. And then finally, that leads me on to the final challenge which we've come across, which is about amending our existing system, EDAM, in order to apply DURI going forwards. And this will require some help from our software developer, but it shouldn't be a major obstacle. So now moving on to the benefits. I think firstly, using DURI will help us avoid using free text usage restrictions, which ultimately enable the restrictions to be more consistent and easier to interpret. Another big benefit for us is that having our datasets tagged with DURI will make them more findable by other researchers who are interested in using certain datasets in their research. And this can be done using the EGA DURI search functionality. At Sanger, we want to make our data as open and accessible as possible, so improving dataset findability is a huge benefit. So finally, and just quickly before I finish, I wanted to talk about the impact of DURI so far. So we've been collecting data on how researchers discover our datasets since 2015. And this pie chart shows that the EGA, publications and other researchers are the most common sources that data requesters use to identify our datasets as relevant for their research. Now, when we applied DURI to our cancer datasets, we wanted to measure the impact of DURI on dataset discoverability. And this pie chart shows that DURI is already being used as a method for discovering our datasets. Now, I should point out that this is a very small sample size and it was collected over a short period of time. But I just wanted to point out that it's good to see that DURI has already helped locate datasets. And we hope that this little brown segment will get even bigger over time as DURI becomes more widely used and recognised among the scientific community. So I'm going to finish off here, but if you have any questions or would like to know more about how we have used DURI, I've left my contact details on this slide, and please feel free to reach out.
My name is Hoichi Ogishima from Tohoku University. It is my great pleasure to introduce our use case of dual code in the Biobank network in Japan. For promotion of research and development of the precision medicine, we have developed the Biobank network connecting the three major biobanks, Biobank Japan, Tohoku Medical Mega Project, and the National Center Biobank Network, and the clinical biobanks, university hospitals biobanks in Japan. Our biobank network stores over 800,000 biospecimens and over 200,000 genomic data, provided by over 400,000 donors. We have provided Biobank research system, which enables users to find biospecimen data across 12 biobanks in our biobank network. We are planning to provide one-stop service for smooth access to biospecimen data. In our biobank network, we standardize the minimum common data elements: participant sex, disease history, biospecimen type, disease name, age, and analytical data type, vendor, and platform. And users can search biospecimen data with the condition of then. If users find suitable biospecimen data, they can inquiry to each biobank and will access the biospecimen data in each biobank. After research authentication, users can search biospecimen data by disease name and the code in the ICD-10 code, sorry, in Japanese, and can get the search results like this. In response to great demand from industry, we decided to add the consent information to our minimum common data elements among biobanks. Since GA4GH has standardized DUO, Data Use Ontology, for consent-based data use conditions, we decided to use this as the standard. Among 23 types of DUO codes, at first we decided to use 2 DUO codes. One is IRB, which is defined as requiring submission of institutional review board approval, and another is the NPU, which is defined as use of data is limited to not-for-profit organization, not-for-profit use, and non-commercial use. By the way, these pictograms are designed by Akio Nagano in the GEM Japan project. We believe these pictograms are great helps for researchers and donors to understand the meaning of DUO code. In the next version, which will be released in this autumn, just 2 months later, users can research biospecimen data by consent information like this. And in the participant detail view, users can browse life course collection of biospecimen data with this history provided by a donor. Users can also look up the consent information represented in the GA4GH DUO code. By the way, in Japan, most studies obtain the informed consent for scientific research use, not limited to not-for-profit organization. To DUO code be used widely in Japan, we need another new DUO code for scientific research use, covering both for-profit organization and not-for-profit organization. Thank you very much for your attention.
Hello, everyone. I'd like to thank you for the opportunity to present here at the GA4GH Plenary today. And today I'll be speaking a bit about how we implemented the Data Use Ontology by GA4GH within the H3Africa Consortium. So for those not familiar with H3Africa, it is the Human Hereditary and Health in Africa Consortium, a consortium which facilitates fundamental research into diseases on the African continent, while also developing infrastructure, resources, training, and ethical guidelines to support sustainable African research enterprise. The consortium consists of 51 projects that include population-based genomic studies in communicable and non-communicable disorders and diseases in Africa, and has thus far recruited well over 90,000 research participants. Funded by both the NIH and Wellcome Trust, these projects are mandated to share the data generated by them to the wider scientific community. H3A BioNet is one of the H3Africa projects. It is the Pan-African Bioinformatics Network for H3Africa and consists of several nodes across Africa as well as a partner institution in the US. H3A BioNet supports the development of bioinformatics capacity across the continent and is also responsible for submitting the data generated by H3Africa to the European Genome-Phenome Archive. So the following diagram illustrates the data lifecycle for H3Africa data. Once the data is generated by the research project, it is sent to H3 Bionet for 23 months and is archived there for 23 months, from which is then submitted to the EGA. So during this archive period, we collect the original consent forms employed by the specific project and then match secondary use to the applicable DUO terms. So I'm going to take a moment to speak about the challenges we had while implementing DUO. We were a group of new team members mapping the data use. And initially, we had some confusion with employing DUO. Firstly, there was a bit of confusion with the distinction between primary and secondary data use categories. This was something we couldn't easily clarify by using the supporting material and the reading material. So it took us some time to wrap our minds around how the ontology is structured. In addition, some of the codes and definitions we found were not very intuitive. Because our mapping involved several projects, it also required a lot of communication with PIs. And during these communications, we could specifically identify terms or definitions that weren't really intuitive and people struggled to understand. Some of these included no restriction or the research-specific restrictions terms. Secondly, there was some dispute with regards to commercial use and how that is exemplified or specified within the DUO ontology. We realized there is a discrepancy between how some organizations determine whether secondary commercial use is allowed as opposed to H3Africa. This is likely due to the historical exploitation of African populations, but our ethics committee felt that commercial use needs to be specified within the consent form, otherwise it's not allowed for secondary use. Where some other initiatives felt that commercial use isn't often specified in consent forms, therefore it should be automatically applied. So there was some tension as to, with regards to how we should implement this and if the ontology should be used at all. So I'll move on to some of the successes. During the initial mapping phase, we worked and communicated a lot with the DUO development team, and we were grateful for that communication because that really allowed us to understand the ontology much better. It provided a lot of clarity on the initial confusion we faced, and I think it also allowed for the ontology itself to be improved. So we made several DUO recommendations during this process and improved some of the existing definitions. Thus far, we've mapped 20 H3Africa projects to the DUO ontology, 8 of which are already sitting within the EGA. Frequent data use requirements we found were collaboration required, ethics approval required, and non-for-profit use only. And then data use categories range from disease-specific to general research use. Continuing on from the commercial use discussion I had earlier about whether an overt statement is required versus not required, we also found clarity on this and how the ontology can be used for both scenarios. By using the non-for-profit only specifier, we could identify data sets that didn't explicitly specify commercial use within their consent forms. But we also recommended that the definitions for data use categories are adjusted so that the definitions clearly specify that commercial use is automatically assumed. And if commercial use is not applicable, then users should apply the non-for-profit use only specifier. In addition, we made some recommendations to add new terms as well, including training use and feedback findings, which has since been proposed to be incorporated with an existing term called return to database or resources. So I think the takeaway message here would be that working with the team really helped us a lot. We felt it was very beneficial for both parties. And it was really good working with the team, and we hope to continue to work with the team to resolve any discrepancies or issues when it comes to secondary use mapping. So with that, I'd like to thank the H3Africa project PIs as well as the H3 Bionet PI, Nikki Mulder. I'd also like to thank the DO development team as well as the consent mapping team from H3 Bionet.
Hi, my name is George Philip Krog. I am Chief of Legal Counsel of Signatu. The topic for this presentation is how dual consent clauses are used by Signatu, including the details of the implementation process. Signatu is a software as a service consent management platform with a complete toolkit for managing consent. Here's how it works. The data collector and data holder, typically a hospital, integrate with Signatu. The hospital would specify the dual consent clauses in an editor or select a template with readily available dual consent clauses. The editor models and structures all necessary elements in several languages. The editor has implemented and uses the W3C standard vocabulary and the Global Health Alliance for Genomics and Health's DUO clauses. Then, Signatu automatically records and stores when the dual consent clause text was created and when the text was last updated. Then the hospital would automatically generate designed consent dialogues with dual clause text integrated and with checkboxes, buttons, or switches to indicate consent choices. Then the hospital would integrate consent dialogues into its website, app, etc. to present and request consent from the data subject. Then the data subject would make her consent choice. Then Signatu would automatically record and document the data subject's consent choices using Signatu REST API directly from any environment that can do HTTP post requests. The architecture allows Signatu to handle millions of events every minute. The consent register is unchangeable. Then Signatu can issue consent receipts to, for example, the data subject. The consent receipts are cryptographically signed. Then the hospital could send to other IT systems events that depend on or need to know about events. Such events can be sent by email, by webhook or webhook API, by Amazon Simple Queue Service, and Microsoft Azure Service Bus. We also have a plugin for Google PubSub in development in alpha. One can use the event data to trigger actions in other systems. Then the hospital may want to, for various purposes, search data subjects' consent choices and may also want to retrieve consent statistics for analytical purposes. Now I will give a few comments on the strengths and weaknesses of the dual consent clauses. We ask, which information must the controller provide in the consent request? Duo has purpose categories. Good. Duo has purpose descriptions. Good. But Duo does not separate purposes from other specific information. Duo lacks specification of personal data and source of personal data. Duo lacks specification of processing operation and method. Duo lacks specification of recipients of personal data. Duo lacks specification of recipient country. Duo lacks specification of data storage period and other technical and organizational methods. Duo lacks specification of legal basis. Duo lacks specification of risks. Duo lacks international language representation. Duo lacks information quality requirements for clauses, consent dialog design, and consent choices. Duo lacks accessibility requirements for clauses, consent design, dialog design, and consent choices. Thank you. Goodbye from Signatu.
Okay, thank you so much to all of our speakers. Now, Jamie is going to give us a quick wrap, and hopefully we will have some time to take some questions.
Hello all. In the interest of time, I just again want to thank all of the speakers who were able to provide us such wonderful presentations today, and just open it up to all of you for some questions. Please, as Melissa said, please stick them in the chat and we will get to as many as we can before the break. Thank you so much for coming today.
You can also raise your hand and I can unmute you so you can speak.
Hi, can you hear me?
Yes, hello.
Oh, okay. So I wanted to comment on the last speaker. It was really great to say, to point out a lot of weakness, like what is lacking in the DUO. However, I feel like what he requests is more than a digital consent form rather than the DUO. I'm not sure about, so I'm just a newcomer, but I'm not so sure about the dual scope. Will it extend to covering the consent form, or because there are some effort ontologies to working on consent form consent as well. Thank you.
Hey, Asia, it's Melanie here. Great to see you in this session. And great point. George made a great point on things that are not in view at the moment. And as you've, I think, rightfully noted, there's a lot of those that we actually have not included as part of the scope of view at the moment. I'm happy we have a little dashboard where we can talk into more details, but specifically for the consent form, I know you've been working with the informed consent ontology as well, so we've reached with them too. We've worked with the regulatory and ethics work stream, the rules in GA4GH, and Jonathan may be able to add more information there. We've developed a way to embed the dual term in the initial consent form, such that when the patient is presented with the consent form, the text they have is mapped in the consent form to a dual term. So we don't go around representing the whole of the consent form like the ICO does, but we're trying to provide that mapping from the beginning.
Yeah, thank you so much, Melanie, and I'm very happy to see you here too. I'm not saying that you should use the informed consent ontology. I'm just, I really like the DUO's approach that is being implemented in a lot of applications. Just, I'm just thinking that the last presenter might request too much from DUO. That is what I want to say. Yeah.
Yeah, let me see if I can post a link. So can I post a link? So we were trying to, and again, the feedback is really useful. So we are trying to think about, which of those we should think about. So some of the ones that Georg highlighted, so specification for personal data and source of personal data, I don't think that's in the scope or the scope that we can foresee in the immediate future. But things around, specification of the data storage period or the legal basis, maybe those are things we need to consider, but we definitely need help and driving use cases. One of the things we've really tried to do has been, using the community and using their needs as driver. And I think Lyndon mentioned that very nicely into the H3 talk as well. It's really, what do you need to use it for and how can we make it useful for you? So if there are some of those requirements that you think are useful for your community, please let us know and we'll work with you on incorporating them.
Great, thanks. And Kathy, you had a question?
Yes, actually, I was sort of headed in the same direction with the last presenter who identified a number of gaps that seemed beyond the scope of what data use ontology was originally designed for. And I just wanted to understand a little bit more about the cases that Signatu is trying to cover, where the use of the data is governed by some things like the storage duration and some of the other gaps that were identified.
Okay, so do you want me to comment on that?
Yes,
Sure,
please.
and I just want to note we have a break that is to happen now, and so if people need to jump off, I understand, but we can let this go on for a few more minutes so we can get some more feedback.
Great. Yeah, so Signatu has provided in its consent management platform fields that map to both the new ISO 29184 and also the consent requirements specified by the General Data Protection Regulation and also guidelined by the European Data Protection Board. So maybe the GDPR is stricter or requires more information than other consent regulations around the world. But we have then tried then to make fields with ontologies for each field to make a very flexible specification. And so we don't impose anything on anyone, but we simply make this available in the specification tool, and then it's up to our users really to make use of them or not.
Thank you for that clarification. But both of those standards, I'm not necessarily intimately familiar with them, but it sounds like they are not just for data use, but they're also for sample use. And therefore, that might explain the additional fields required for that.
Yeah, so for example, the General Data Protection Regulation says that consent needs to be given for a specific purpose. And that is good with the DUO consent purpose clauses, I think. But in addition, this regulation requires that you need to specify the data for the purpose and some other specifications, but that requires then a field with preferably an ontology for the personal data that are being processed in for some research purpose. And that field is very difficult to develop. And I can understand very much that Melanie says that that will be some way down the timeline.
Thank you.
Okay, we can take one last question if anyone wants to raise their hand.
I think I would add that if any of the use cases that our speakers have presented or in this discussion are of interest to you, we would really love help from your community in making it the most useful we can. So Melissa, I don't know if you have the ability to add people to the mailing list, but please let Melissa know. We have a discussion mailing list, everything's under GitHub, submit tickets, or, you know, we'd love to talk to you more about your needs and how we can answer them.